Pluto is a far-off and strange bantam planet, which was once an individual from our planetary system's planetary family. Anyway, late surprising declarations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have carried Pluto back into the spotlight with a stunning disclosure. They suggest that this cold world is on a potential crash course with Neptune. But how is it that this could work out, and what might be the results of such an enormous event? Are we seeing an uncommon galactic peculiarity, or is there something else to this looming vast crash? Join us as we investigate the possibilities of a Pluto-Neptune influence. Pluto, a previous planet that was downgraded to a bantam planet, partly due to its unique orbit, remains a subject of interest and study in the cosmic community. According to recent predictions by leading researchers, Pluto's orbit is perilously close to Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a potentially dangerous impact between these two planets that could be a colossal threat to Earth. How is such an event even conceivable? Pluto's journey around the Sun is unlike any other planet in our solar system. It requires an amazing 248 years to complete a single orbit, meaning that since its discovery in 1930, it hasn't even completed one full revolution. Yet, the intrigue doesn't stop there. Pluto's orbit is marked by its highly elliptical shape, straying significantly from the near-circular orbits of the major planets. What makes Pluto's orbit even more curious is its tilt, calculated at 17 degrees to the ecliptic plane. The path Pluto follows is much steeper compared to the other planets. This tilt and eccentricity add layers of complexity to its orbital pattern. One of the most fascinating aspects of Pluto's orbit is its intersection with Neptune's path. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect from their positions in the solar system. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to understand its unique trajectory. Unlike the other planets, whose orbits lie mostly near the ecliptic plane, Pluto's orbit stood out with its steep tilt and elliptical shape. The mystery grew with the realization that Pluto's orbit actually crosses Neptune's. The stability of Pluto's orbit amidst these complexities is evidence of the intricacies of space mechanics. The three-body problem in space is about figuring out how three objects like Pluto, Neptune, and the Sun move and influence each other with their gravity. It's like trying to predict where they will go based on where they start and how they pull on each other. In Pluto's case, this problem demonstrates how its orbit, Neptune's orbit, and the Sun's gravity all interact in a complicated way. The terms alibrations and scope librations, along with the VZK oscillation, are part of this puzzle. According to astrophysicists, what's keeping all planets in their orbits is azimuth libration. With regard to Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, it's positioned no less than 90 degrees away from Neptune. This spatial division is crucial in keeping their orbits from colliding. Scope libration, on the other hand, refers to the upward movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it's positioned above their orbital plane, providing an extra layer of protection from potential crashes. Another key factor in this scenario is the VZK oscillation, named after three researchers, Bond, Zippel, and F, who studied how objects move in space. It's about how three space objects, Pluto, Neptune, and the Sun, pull on each other with their gravity. This pulling affects how they move. In Pluto's case, the VZK oscillation helps us understand why its orbit around the Sun is so strange. Despite Pluto's orbit appearing chaotic, this oscillation helps keep it moving smoothly. Understanding this orbit is really important because it gives us a clearer picture of the solar system's dynamics. The framework's dynamic nature, the situation of Pluto, shows the way that even the most apparently temperamental circles can accomplish a condition of harmony through the perplexing exchange of gravitational powers and orbital mechanics. It additionally shows the significance of non-stop perception and investigation of these peculiarities to get a handle on our spot in the universe better. Investigating the profundities of space frequently drives us to stand up to the eccentric nature of divine bodies, and Pluto's circle is a great representation of this flightiness. The idea of orbital turmoil, which alludes to the delicate dependence of a divine body's way on its underlying circumstances, is distinctly shown on account of Pluto. This implies that even slight varieties in the Bantam planet situation or speed can fundamentally change its drawn-out circle. Utilizing virtual experiences has been really useful for researchers to sort out how Pluto moves in space. These recreations utilize precarious math to copy how Pluto and other space bodies, like Neptune, pull on one another. By changing little subtleties in the reproductions, stargazers can perceive how even small changes can have a major effect in where Pluto returns. In the last part of the 1980s, these reenactments showed something truly fascinating about Pluto's way. Despite the fact that it has things like azimuth and scope libration to keep it consistent, its circle can in any case be wild and flighty. In the event that you get going with only a small contrast in where Pluto is or the way that quick it's moving, over numerous years its way can wind up looking truly changed. Yet, even with this disorder, Pluto's circle stays stable for quite a while, like billions of years. This implies Pluto's excursion around the Sun has a sort of request to it, despite the fact that it appears to be out of control at first. Foreseeing enormous occasions, particularly when they include turbulent circles like Pluto's, postures critical difficulties. The innate unusualness of these frameworks implies that drawn-out gauges are frequently full of vulnerabilities. While mathematical reproductions give a solid means to comprehend and expect the future ways of divine bodies, they additionally highlight the impediments in our prescient capacities. These models depend vigorously on the exactness of starting circumstances and the intricacy of the collaborations they mimic. Any slight blunder or misrepresentation can prompt unfathomably various results, making exact forecasts an overwhelming undertaking. Additionally, the tumultuous idea of heavenly circles like Pluto helps us to remember the steadily developing and dynamic nature of the universe. While we have taken huge steps in understanding space, the instance of Pluto reminds us how our insight about the universe actually stays restricted. Understanding the gravitational impacts of the monster planets on Pluto's circle gives significant experiences into the more extensive elements of the planetary group. It demonstrates the way that the presence and position of every planet can have sweeping impacts, affecting the strength and direction of different bodies inside the framework. So why are significant astrophysicists just now raising worries about a potential crash between Pluto and Neptune, regardless of this multitude of mind-boggling powers attempting to hold such an occasion back from happening? Neil deGrasse Tyson, an unmistakable astrophysicist and an urgent figure in promoting cosmology, gives a novel viewpoint on the secrets of our nearby planet group, especially the captivating instance of Pluto. Tyson, known for his job in the renaming of Pluto from a planet to a Bantam planet, offers clever discourse on the developing idea of divine mechanics and the public's interest with the obscure domains of space. Tyson's position on Pluto's renaming is established in the consistently extending information on our planetary group. He sees the renaming as not a downgrade but rather a vital variation to our developing comprehension of the many bodies circling our Sun. Tyson's way to deal with divine mechanics is one of ceaseless learning and transformation. He sees the intricacies of orbits, for example, Pluto's, as a sign of how much there is still to find in space. The interest of these questions, particularly the potential interactions among Pluto and Neptune, highlights the dynamic and erratic nature of our nearby planet group. His work underlines that the more we unveil about space, the more inquiries emerge, pushing us to investigate further and refine how we might interpret the universe. Michio Kaku, another famous physicist and futurist, offers an alternate yet free point of view on the secrets of space, zeroing in on the frequently capricious powers that shape our universe. Kaku is known for his capacity to connect complex logical ideas with cutting-edge dreams, making him a critical voice in discussions about divine mechanics and the more extensive ramifications for mankind. Kaku's perspectives on Pluto and its circle stress the requirement for persistent perception and high-level displaying to expect and comprehend potential grandiose occasions. He sees the cooperations between divine bodies as a pivotal area of review for scholastic interest as well as for pragmatic ramifications. The likely impact between Pluto and Neptune, for example, isn't simply a hypothetical situation, but a sign of the dynamic and frequently tumultuous nature of space. Kaku's futurist viewpoint pushes us to consider the more extensive ramifications of such occasions, from the impact on how we might interpret the nearby planet group to the possible requirement for future space mediations. Kaku's viewpoint highlights the significance of being ready for the unforeseen in space. His work proposes that the more we comprehend the powers at play, the better prepared we will be to explore and possibly relieve the impacts of astronomical occasions. Both Tyson and Kaku's perspectives combine on the possibility that space is a domain of perpetual discovery, and that our current understanding, while tremendous, is still limited. Their emphasis on the requirement for constant investigation and high-level displaying mirrors the developing idea of room science. They highlight the significance of not understanding heavenly mechanics as they are presently but speculating how they could change later on. The potential impact between Pluto and Neptune serves as a contextual study for the more extensive difficulties and opportunities in space investigation. It highlights the requirement for hearty logical request, cutting-edge innovation, and an eagerness to adjust our comprehension as new data arises. For Tyson and Kaku, the secrets of space, exemplified by Pluto's circle, are a source of inspiration for mainstream researchers and humankind on the loose to continue to push the limits of our insight. There is an overall logical agreement that for years to come, the circles of Pluto and Neptune will remain stable because of their mean movement reverberation and the different gravitational impacts following up on them. Thus, a direct impact between Pluto and Neptune is extremely unlikely. However, the intricacies and potential irritations in orbital elements imply that space experts should proceed to monitor and concentrate on these heavenly bodies to more readily comprehend their drawn-out ways of behaving and any potential dangers they could present. While the situation of a Pluto-Neptune impact is generally speculative and considered unrealistic with our current understanding, it highlights the significance of consistent examination and perception in cosmology. Advances in innovation, including further developed telescopes and programmatic experiences, will assist space experts with refining their models and expectations, ensuring that we stay informed about the dynamic and ever-changing nature of our nearby planet group. Tyson's viewpoint on Pluto's renaming and Kaku's accentuation on the flighty idea of heavenly mechanics both highlight the requirement for persistent investigation and an adaptable comprehension of our universe. The potential impact situation, while highlighting the dynamic and complex communications inside our nearby planet group, ultimately helps us to remember the immense, still unknown regions in how we might interpret space. Through continuous exploration and perception, we endeavor to unravel these secrets, guaranteeing that our insight stays up with a consistently developing universe.